Okay, today's focus will be on arc length and surface area.
Are you recording?
Yep.
Okay. Just making sure, because Lily's not here.
This looks not fun.
Tomorrow's focus will be on work. Thursday, you will review for a quiz on Friday. Okay. That's up. That's okay. So we want to find the arc length from here to here. Okay. Now, as the crow flies, we can find that distance, right? With the distance formula. However, I want to find that curve length. Like if we were to put a piece of spaghetti over that, and then we stretch it out, how long is that piece of spaghetti? Okay. It's all about food. All right. So let's think about it.
But what value does that give you in proportion to the function?
Spaghetti. That's the code word. That's the code
I'm
word.
just wondering what value this gives you in proportion to the function. It should just give you like the total distance that the line goes.
Well, like if I were to take a walk on the curve, like it would be the distance we would get to walk on the curve. Does that make sense?
So if you were to use this, it would be like find the distance of a path.
Yes.
Are sine and cosine special?
So let's talk about the distance.
Is like the arc length of sine and cosine special?
No. I mean, I don't think they're special. But I suppose I've never like.
I don't know. That was
Okay. So let's take these two coordinates, random coordinates. Okay. P sub I and P sub I minus 1. Okay, we're going to get into some funky notation here, but just go with me. Okay. So a point and a point before it. That's what I'm talking about. Okay. If we were to find the distance between 2 points who are really super duper close together, right? We could just use the distance formula, right? How do we do the distance formula? X minus x squared. Okay. Y minus y squared. Okay. What is a calculus way to describe x minus x? I'm maybe in more of a physics way. Right now, I'm gonna put change in x squared. And how could we describe this?
dx plus dy.
Okay. Well, then I'm going to use a trick. I'm going to take what's underneath the radical, and I'm going to multiply it by change in x squared over change in y squared. Okay. When we multiply that through, oh, no, I'm sorry. We can't do that. That would be illegal, wouldn't it? Change in x squared. We have to multiply by 1. Okay. This is not something I'm expecting you to remember. I'm just showing you where the formula is coming from. Okay. So when we distribute this through, okay, I am going to leave this undistributed, and I'm going to distribute the denominator through. Does that make sense? So we would get 1 plus change in y squared over change in x squared. And then that delta x squared, which is underneath the radical, we could take out to be delta x.
Is that
Not anymore. under the radical it was delta x squared. So taking it out, it becomes delta x. Okay, so it ends. Okay. So now what we want to do is we want to take these two coordinates and get them really close together and then add a bunch of them together.
Did the delta x get out from under the
Yes, because underneath it was delta x squared. And so when we take it out from the radical, it's now delta x. Okay. So what calculus thing can we do where we take things and we make them really close together, then we add them all up?
I think it has to do with the one.
But then wouldn't delta x squared become 2? Delta x is 4 over delta x squared.
Well, I distributed only the denominator through and kept this guy outside. Okay, and then we can take the square root of delta x squared to just be delta x. Okay, so now we can add a bunch of little distances up by taking the integral. Okay, this is what you need to know. I'm just showing you where it came from. Okay, and we wouldn't necessarily need that I anymore. I've showed you how mathematicians got our arc length formula, but in order to find the arc length from A to B, we need to take the integral from A to B of the square root of 1 plus f prime of x squared dx.
I like it a lot. Pretty groovy, you know. We're trying to bring the word groovy back, just so
Why
everyone's
not
aware.
tubular?
That's the code word today. Groovy.
Tubular.
It was spaghetti.
Groovy spaghetti.
Tubular spaghetti.
Tubular spaghetti.
All right, do we have this written down?
Do I have grubular spaghetti written down?
So
I mean, it's the only important thing.
That just sounds like spaghetti with a lot of grooves.
It's like a
lasagna.
yeah.
Lasagna.
What is the definition?
I can't do actual math.
Like a
Sure
divot.
can talk about pasta.
Or what is that that tube pasta that you can like fill?
Yeah.
Penne?
No, the big, the capit,
Rigatoni?
manicotti.
What?
Oh,
The fancy
I
word.
wish
It's
I could.
like that big
Wait,
amount.
what?
Wait, you don't
It's
have to
you
like
little woman over there.
I'll bring in a different pasta dish.
Okay,
Sorry.
what?
Are we gonna have
Name
using
it.
it? Do we have using it like?
calculus.
No, we
Yeah,
have
what's
using
up, guys?
it.
Radical
Yeah,
rigatoni.
I'll need to bring
Is
it
it that? Is it happening?
Yeah, it's happening.
All right, let's
Right.
focus. Let's focus.
Super.
Garage smells like carcasses.
When I miss class next year and have to show this video, you don't let next year's class be like, what was going on?
No, that would be funny.
Okay.
If Caleb doesn't sign up for BCM, it'll be significant.
Bamboozling.
All right, here is our curve, and I want to find the arc length from 1/2 to 2. So that little blue piece right there. What is that arc length? Okay, so what do we need in order to set up the integral for arc length?
The derivative.
We need the derivative. So our derivative, x cubed over 6 goes to, let's try that again.
X squared over 2.
I know, we're mixing integration and derivatives at once. Derivation
Is that the word? Can it be the word?
can be the word. Okay, and what about the derivative of 1 over 2x?
Negative 1 over 2x squared.
Okay, I like that there's a little bit of a pattern going on here. That could be good. That could be good. Okay. By the way, we are doing this one by hand.
I don't know.
So our arc length is going to be the integral from 1/2 to 2 of the square root of 1 plus our derivative squared dx. Mrs. Holman, we are doing this one by hand. Yes, we are. Okay, what did you suggest, Jackson?
Should be able to simplify the derivative.
Well, that derivative is being squared, right?
Yeah.
Let's square it.
Yeah.
That will actually simplify it a lot because then an x squared will go into the numerator and make a normal number instead of a variable.
Okay, so we have x to the 4th over 4. What would x squared over 2 times negative 1 over 2x squared be?
Negative 1/4.
Okay, and we have that twice. And then plus 1 over 4x to the 4th. Are you okay with how I got that to that negative 1/2?
Yeah.
Why don't we just do it?
Because I've never been good at just.
So a minus b times a minus b, we get a squared minus a times b minus a times b, it happens twice, plus b squared. So that negative 1/2, I thought about what a times b would be,
Okay.
and then I doubled it.
Oh.
Are you with me? Okay. So now,
You plug it into your calculator.
We'll do it by hand because our hand is pushing all the buttons.
You can just
We'll just
try.
confirm the answer.
I'm writing it in a specific way. Do you notice anything?
There's
About-
an integral.
Thank you.
Well,
Is it
the x to the 4th is kind of on the opposite side of the fraction.
Oh.
Do those two look very, very similar?
Yeah.
One has the subtraction for 2ab, one has the addition for 2ab,
Oh.
which means we know how this factors. We know that this is going to factor to x squared over 2 plus 1 over 2x squared squared. And why is that exciting?
Because you got a squared and you got a square root and they fight. Cancel out.
Okay? And since we're going with the positive values, then that will work out just fine. Okay? So really what we have to worry about is the integral from 1/2 to 2 of x squared over 2 plus 1 over 2x squared. And that is something really neat. Isn't that beautiful?
Yes.
How it worked out that way? You can keep your comments to yourself, but
It's like a pretty child
Life
and then
finds
like
a
a pretty adult, but like a really ugly teenager.
Life finds a way.
Okay. I like the analogy. All right, what is our antiderivative here?
The number.
Jackson, I'm going to let you redeem yourself here. What is our antiderivative for x squared over 2?
Are we not gonna
X
just-
cubed
we're
over
gonna go back
6.
to like the original function almost.
Ish.
Ish. Yeah. So it'd be x cubed over 6.
Hey, wouldn't this
Okay.
just become the original function?
Almost, because it's going to be subtraction, right?
Well, that's great.
Does it always do that, or is this just unique?
I
Is
think
there always a pattern?
there's going to be a pattern in problems like this because of how we get because we have a function, we have to take its derivative, and then we finagle it around,
Yeah.
and then we have to take the antiderivative. So
But is there like a pattern that can make things a lot easier that you can just give us and just?
Can the pattern be that we never do problems like this after today?
You will have a problem like this again. I'll save us some time. It's 33/16. Okay. Plugging in that 1/2 isn't really.
Fun.
No.
You may
Doesn't it
not
give
think
you-
of it as fun.
Doesn't it give you 47/48 or a negative 47/48?
No, it should give you
Oh,
33.
No,
Oh, this.
The 1/2.
The 1/2 would give you
It would give you
1/48.
It would give
And then
you.
minus 1 is negative 47. That's what you said.
Okay, so
Sorry.
I did that right. That's
Yeah.
good. That's good.
But then you have to make a comment denominator, and we'll just save some
Spooky.
time. Okay, so let's kind of figure out, is our answer reasonable? What would the line of sight distance, like what would the distance formula distance be between these two
I
coordinates?
didn't even see the picture.
Well, I mean,
Oh, it's dependent on.
Here's the picture. Huh. It's all in the same one. So like if we did the distance formula, we're finding the distance between the coordinate 1/2, 49/48, and 2 19/12. Okay, I've already calculated.
I don't
I think
Do you expect us to find the distance formula?
No.
good.
We're in calculus.
But
We're above those things.
Okay.
That's still-
But if we plugged into our geometry distance formula, even algebra 1 is where you learn it, right?
Yeah.
That was
Isn't that
seventh
amazing?
grade.
Yeah.
I was a child.
How many of us were in that class?
We would get 1.602 yada yada yada. So 1.6. If this distance from here to here is 1.6, is it reasonable that our arc length would be 33/16?
Yeah, because it should be longer.
It should be significantly longer because it's up and down, right? Okay. Excellent.
Miss Homan, did you put us on that table on purpose of like the algebra 1 kids, the latecomers, the late.
Spooky.
I don't know your background.
Sorry.
Wait.
You guys are so mean.
I do not know your algebra 1 background. Here's our next example.
Isn't that funny?
I think that's a
And
little.
I love you.
And it's almost used to young ones have next.
all 4 years. Yeah, we just don't have stats for
I had math with Will until he
I mean,
quit.
this is
I know, but like.
He quit last year.
How about being the only
Okay, write it down. Have you ever tried to combine the natural log with cosine? This is what you get.
It looks
Good to know.
like how I'm frowning.
It looks like a board from Star Wars. Like that's what his mouth looks like.
A porg.
Yeah.
You're right.
The best part of that movie was when Chewbacca roasted the porg.
All right. That's not the color I want. In order to set up arc length, we need to know the
Derivative.
Isn't this just the derivative should just be secant of x?
I would not say that the derivative is secant of x because we have
Oh, it would be
1
negative
over
tangent
cosine of x times
sine
derivative
x.
of the inside. We're doing the chain rule in AB right now.
You're already there. So you guys have to.
It is. So negative tangent of x. Could you leave it as negative sine of x over cosine of x?
Yeah,
Sure.
Wow.
But why would you want to? Okay. Because when we go to set up our arc length from 0 to pi over 4, we get 1 plus tangent squared x under the radical, don't
Wait a
reveal
second.
anything to me yet. Just hold it in. Let people catch up with their writing. But get excited.
Oh, is this that sine square?
No.
That looks.
Is everyone okay with our derivative as negative tangent?
Yes.
We have the square root of 1 plus our derivative squared.
Mm-hmm.
1 plus tangent squared is a Pythagorean identity. Which one is it?
Cosine, secant.
Something like that.
Oh,
Can we?
All I
can we
remember
run
is
through-
all I
can we
remember
list
is
that
sine
together?
squared plus
Plus
cosine
sine
squared.
squared.
Okay, what do you remember, Jackson? Say it again.
Sine squared plus cosine squared is 1.
Okay. Now, if we divide everything by cosine squared, we get sine squared over cosine squared plus 1 equals 1 over cosine squared.
Secant squared.
Oh, this equals secant squared.
Oh boy, my favorite.
You can't.
So that's great. We have secant squared under our denominator. Not denominator, excuse me. Radical is the word I was looking for there. We have secant squared, thank you, under our radical, which would turn into
Oh no.
See,
What's the antiderivative of secant?
yeah, it's not a pretty one. So the antiderivative of secant is one that you would have to look up. We have a chart that tells us some of these interesting ones.
I'm guessing it might be the natural log of something.
It is the natural log of something.
Is it the natural log of cosine over sine?
That would be the natural log.
Of no, the natural log of cosine, and then the natural log is divided by sine.
The natural log of secant x plus tangent x.
Oh.
it's okay, guys. There's still 2 numbers in there. We can do this.
We can do.
It's not all letters.
Not all letters.
Sooner or later, it's gonna be like A, B, C. Minus 1.
Honestly, I feel like we should get English credit for this because of how many letters there are.
Okay.
My
It is-
problem
it is
is-
a form.
Darby, what's the secant of pi over 4?
It would be like 2.
Radical 2.
Thank you.
Took me a minute, but I got it.
Plus the tangent of pi over 4. Gabe?
That is.
Minus the natural log of the secant of 0.
Okay, I was right.
No.
Plus the tangent of 0.
That was 0. Yeah, I thought secant was 1 of them.
That's what I thought.
Oh wait, no,
That's
but
what I was
cosine
confused
is
by that.
0 is
I was confused by that.
The cosine of pi over 4 is radical 2 over 2.
Yes.
So the
You get 2 over
reciprocal,
radical 2, which then becomes 2 radical 2.
Oh yeah.
which is
then radical.
Yep.
Brain.
Okay. So, properties of logarithms. Are you okay with my answer here? When we subtract a logarithm, it's like we divide inside, and dividing by 1 is unnecessary. Or you can think of
Wait, where did
the natural log of 1 is 0.
Parentheses are absolute.
Well, is radical 2 plus 1?
Well, yeah.
Okay, then we don't need absolute value. Okay. Yay.
Spooky.
walks up to some like Home Depot contractor. Yeah, natural log of 2 plus 1 pieces of wood.
All right,
Can you get that for me?
here we go. Don't write this down yet. We are going to take this curve and we're going to rotate it around the x-axis. Okay? What I want to find is the surface area. So it's like we're taking our arc length and we're rotating it around and finding like that area on the surface, right?
I see
Okay.
4 symbols.
Just take a deep breath. We're going to take this piece, we're going to rotate it around. So think of this, okay, as we have a circular band, right, 2 pi r, times ds, which is like that thickness of it, right? That would be the area. Are we all good with that? Okay. Now, that ds, is that describing like a really small arc length, essentially? Oh, arc length. Do we know how to do that?
Oh, we do. Oh.
Ta-da.
That's so disgusting.
But it's in terms of what y here.
Well, y will be a function of x. So where it says y, we get to put in the function of x. So everything will be in terms of x because we will replace y.
You
Can you
clarify.
factor out the 2 pi from the integral? So then,
For sure, you can put 2 pi on the outside.
wait, if it's 2 pi, does that mean that it's always the shell method? Or does that just have to do with surface?
Well, that has to do with, like, we have these circular bands, and so 2 pi r was the circumference that we used, okay? And y, like, this is 2 pi r. This is, like, the circumference times its thickness to get that circular, like, band of area. And the integral adds them all up.
Oh no.
Now, I will say that surface area is a bonus topic. Okay, arc length is what we're going to see on the AP test. We might as well talk about surface area while we're here, okay? But I'm going to be more concerned about arc length as we move throughout the year.
Okay, that's this.
You clarified Cartesian. That makes me nervous.
What's Cartesian?
As opposed to.
It's just the
As opposed to, like, are we going to do it?
Oh,
We are going to do arc length when we get to parametric and polar.
We have to do that again?
Another one.
The ordeal.
We calculated and that kind of flew out the brain.
Well, we will fly it right back in.
Okay.
Yes, we will have both a polar and a parametric unit in here, but let's focus on Cartesian. Y equals radical x. We are going to rotate about the x-axis. Okay, so we're going to have 2 pi. My picture is going from 0 to 9. 2 pi r. R is your function times arc length. Okay, for our arc length, we do need the derivative. Okay. You know what's our derivative?
X to the negative one.
So when we square it, we get 1 over 4x. Do you agree?
I have a quick question about the last one.
Yeah?
So it was negative tangent of x, but one still added tangent of x squared.
Because when we square the derivative, the negative's going to go away. Right? Okay. Okay. Now, what's nice about this one is our function was a square root, and we already have a square root. Can we multiply square roots together? We sure can. which means we just multiply what's underneath. So we get x plus 1/4. Okay, and technically we can take this derivative, right? Antiderivative. We can take this antiderivative, right? We can have 2 pi x plus 1/4 now to the 3/2 times 2/3 evaluated from 0 to 9. However, plugging in 0 to 9, it doesn't, that's a little ugly with that 1/4 in there. So you would need your calculator for this anyway, it turns out.
1/4 to the 3.
Well, that wouldn't be scary, but 9 plus 1/4 to the 3/2 isn't really.
Well,
Well, the
you
square
also
root of 9/4 is 3/2, and then you cube that, so it'd be 27/8.
9 plus 1.
That would be 5.
It would be 37/4, wouldn't it?
That's a lot of force.
Okay.
Oh.
Okay.
Just-
Okay.
So I just put the 9 on top.
Way too many force.
No.
Hold on. Okay. Yep.
and,
All right. So here's the deal. We have 12 minutes left of class. I would like you to begin your homework. I think on your goal sheet I specify which ones I want you to do with a calculator and which ones I want you to do without. The ones where you can use a calculator, please integrate from the get-go. Like if I said that this was a calculator problem, you wouldn't do any algebra. You would just put it in right here. Okay? Don't give yourself an opportunity to make an algebraic mistake if you can use your calculator. Okay? So, yay, you get to start your homework. And if you have questions, you can ask me.
Use that.